Hi and welcome to our short recorded demo of the Mirage LS multimodal IR microscope, where we will perform an important life science related measurement. That is the automated IR spectral and imaging measurements of single bacteria at sub-micron spatial resolution. So here we start off having already centered and focused our bacterial sample like one would do in a traditional optical microscope. Here we switch back and forth between the autofluorescence channel and bright field channel to look for additional information and contrast. And as you can see, these bacteria exhibit some strong inherent fluorescence. One could then either use the bright field or autofluorescence images to guide your subsequent IR measurements. Here, I continue with the bright field image. For an initial sample exploration, we'll mark out 3 random points on the bacteria, some single and some clusters for spectral measurements using the array tool. As you can see, the spectra are being collected with only a single scan, with high sensitivity, all within a couple of seconds per point. Satisfied with the data quality, we'll now move across the set of a featurefindIR IR measurement to automatically locate and measure all the bacteria in the field of view. The bottom left-hand pane of the featurefindIR window shows a histogram distribution of the image pixel response, so we'll just adjust the upper and lower thresholds to get a good image segmentation of the bacteria. We'll hit Calculate, where it'll generate some particle size statistics, and then we'll hit Accept. With those locations now transferred to the array tool, we can see we have 124 particles detected, so we can simply hit Acquire Array to start the measurements. Here we can see spectra from individual 1 micron bacteria being acquired with sub-micron infrared resolution in only seconds. And for the sake of the demo, the middle section will be sped up. Having collected over 100 spectra in minutes, you see how reproducible the spectra are and devoid of any scattering artifacts. With the automated spectral measurements complete, we'll switch to single frequency imaging mode. Here, I simply draw my IR imaging measurements box over the bright field image and hit Accept. Moving to the Image tab, we see the drawn box is about 45 by 45 microns in size. We'll set the image pixel size to about 250 nanometers, which is an oversampling factor of about 2 relative to the probe beam laser spot size of about 500 nanometers. We'll adjust the scan rate and hit Acquire Image. On the left-hand side, we see the single frequency IR image set to 660 wave numbers, which is for the protein, evolving in real time. And once again, for the sake of demonstration, we'll speed the middle section up. On the right-hand side is the so-called DC image, which is simply a measure of sample reflectivity for the green probe laser. Here we can see remarkably how single individual bacteria measuring only 1 micron in diameter are easily and quickly imaged in the infrared, something that would be impossible for a traditional FTIR or QCL microscope. Back in the document view, we see all of our spectra, our segmented image, the protein IR image, ready for easy sample interpretation and further analysis. And that concludes our quick 3-minute sub-micron infrared bacterial, spectral and imaging measurement demo. Thank you.